What is a rocket exactly? I see on the launch they go and start splitting apart till one goes into orbit or beyond.
A rocket is a vehicle that uses a combination of fuel and oxidizer to produce hot gases that are expelled out of the back of the vehicle, generating thrust. The hot gases are produced through a chemical reaction, which is typically the combustion of liquid fuel and liquid oxidizer. The rocket is designed to accelerate upward and escape the Earth's atmosphere, carrying a payload such as a satellite and spacecraft or scientific instrument. During launch, the rocket goes through several stages. 1. The rocket lifts off the launch pad and begins to ascend. 2. First stage. The first stage of the rocket burns its fuel and oxidizer to produce thrust. 3. Staging. The first stage separates from the second stage, and the second stage ignites. 4. Second stage. The second stage continues to burn fuel and oxidizer to accelerate the rocket. 5. Fairing deployment. The protective fairing covering the payload is discarded. 6. Third stage. The third stage ignites and continues to propel the rocket. Separation of stages is necessary to shed weight and allow the rocket to achieve higher speeds and greater altitudes. Each stage is designed to optimize efficiency and performance at a specific point in the flight. The final stage places the payload into orbit or beyond.
Then what is payload?
The payload refers to the object or cargo that a rocket carries into space. This can include satellites, spacecraft, scientific instruments, and even crewed modules. The payload capacity of a rocket depends on various factors, such as the design and size of the rocket, the type of fuel used, and the specific mission requirements.
What do you mean rockets themselves don't go beyond into outer space?
That's correct. Rockets are just the vehicles that carry payloads into space. The rocket itself typically doesn't go beyond Earth's orbit or into deep space. Instead, the payload, such as a satellite or spacecraft, is released from the rocket once it reaches the desired altitude or orbit. The rocket then falls back to Earth, often burning up in the atmosphere or landing safely back on the ground. Some rockets, like the SpaceX Falcon 9, are designed to be reusable and can return to Earth after launch. But they typically don't venture beyond low Earth orbit. It's the payloads that are designed to explore deeper space, such as the Moon, Mars, or beyond.
What kind of fuel do rockets use?
Rockets can use a variety of fuels depending on the type of rocket and the mission. The two primary types of rocket fuels are liquid and solid. Liquid fuels are typically a combination of a fuel and an oxidizer, such as liquid oxygen and kerosene, or liquid hydrogen and oxygen. Solid fuels are typically a combination of an oxidizer and a fuel, such as ammonium perchlorate and aluminum. Hybrid fuels combine elements of liquid and solid fuels using a solid fuel and a liquid oxidizer. The specific fuel used depends on factors such as the specific impulse required, the desired thrust-to-weight ratio, and safety considerations.
You're talking about terms oxidizer and fuel. What are they exactly?
Great question. In the context of rocket propulsion, an oxidizer is a substance that supplies oxygen to the fuel, allowing it to burn and produce hot gas that can be expelled through a nozzle to generate thrust. The fuel, on the other hand, is the substance that burns in the presence of the oxidizer to produce the hot gas. In a liquid-fueled rocket, the oxidizer and fuel are typically stored separately and mixed together in a combustion chamber, where they react to produce a hot gas that is then expelled through a nozzle. Common oxidizers used in rocket propulsion include liquid oxygen, L-Luquaz, liquid fluorine, F2 nitrogen tetroxide, N2O4, ammonium perchlorate, NH4ClO4. Common fuels used in rocket propulsion include kerosene, RP1, liquid hydrogen, LH2, liquid methane, LCH4, solid fuels like ammonium perchlorate and aluminum, AP, all. The specific combination of oxidizer and fuel used, the Apollo 11 mission used unsymmetrical dimethylhydrazine, UDMH, as fuel and nitrogen tetroxide, N2O4 as the oxidizer. The Apollo Service Propulsion System, SPS, used this hypergolic propellant combination, which ignites spontaneously upon contact, ensuring reliable and immediate ignition.
Oh, was that better than liquid hydrogen and oxygen?
No, liquid hydrogen, also called LH2, and liquid oxygen, known also as LOX, are generally considered a more efficient and powerful propellant combination than UDMH or N2O4. LH2 or LOX has a higher specific impulse, a measure of efficiency, and a higher thrust-to-weight ratio, making it better suited for high-performance missions like sending humans to the moon. However, UDMH N2O4 has its own advantages, such as being easier to store and handle, and being more reliable and forgiving in terms of ignition and combustion. The Apollo SPS used UDMH N2O4. Additionally, rocket fuels require specialized storage and handling, adding to their overall cost.
So, now why don't the astronauts and rocket engineers use our day-to-day car fuels to obtain thrust and beyond?
Great question. While car fuels like gasoline or diesel are much cheaper and more accessible, they aren't suitable for rocket propulsion for several reasons. Deal 1. Specific impulse. Car fuels have a lower specific impulse, a measure of efficiency, than rocket fuels like LH2 LOX or RP1 LOX. This means they wouldn't provide enough thrust to escape Earth's gravity or travel long distances in space. 2. Energy density. Car fuels contain less energy per unit mass than rocket fuels, making them less efficient for generating the high thrust needed for launch and escape. 3. Combustion temperature. Car fuels burn at lower temperatures than rocket fuels, resulting in less efficient combustion and lower exhaust velocities. 4. Nozzle design.
Experts out there say hydrogen is abundant. Not just abundant, but much abundant likewise to oxygen. Now, how do they turn to be expansive? In fact, gasoline and diesel seems to be more difficult to obtain than hydrogen and oxygen.
You're right that hydrogen is abundant, as it's the most common element in the universe. However, extracting, processing, and storing hydrogen is currently more expensive than refining and distributing gasoline and diesel. Here are some reasons why. 1. Extraction. Hydrogen is typically extracted from water, H2O, or natural gas, CH4, which requires energy-intensive processes like electrolysis or steam methane reforming. 2. Storage. Hydrogen is difficult to store due to its low energy density and the need for high-pressure tanks or cryogenic containers. 3. Infrastructure. The infrastructure for hydrogen production, transportation, and storage is still in its infancy, making it more expensive to establish and maintain. 4. Economies of scale. Gasoline and diesel are produced in vast quantities and have well-established supply chains, which drives down costs. 5. Energy efficiency. Hydrogen production often requires non-renewable energy sources, which adds to the cost and environmental impact. While hydrogen has the potential to become a more affordable and sustainable energy source in the future, current technological and infrastructure limitations contribute to its higher cost compared to gasoline and diesel.
Well, let's put fuels aside. I saw NASA scientists and engineers doing an experiment on the rocket before the launch date. They burnt lots of their...
The rocket is designed to lift off and climb, and the thrust is directed upward and outward, allowing the rocket to escape Earth's gravity. The engines are throttled and controlled to maintain a stable flight path, but the initial thrust is indeed powerful enough to overcome any restraints and lift the rocket off the launch pad. Do not forget to like and subscribe for more videos.